Hello, this is Joshua Scabry, and today we're going to be working on buoyancy. Buoyancy was figured out by a Greek named Archimedes, who discovered that if the weight of an object being placed in the water is less than the weight of the water displaced, the object will remain afloat, and this is known as buoyancy, or the Archimedes principle. Ships made out of metal are able to remain lighter than the amount of water they displace because that is not a complete solid. The very bottom of the ship, called a hull, is hollow and therefore adds support to the ship without adding any mass. When a ship is fully loaded, there is the maximum amount of weight it can carry before the weight of the ship increases past the amount of water it displaces. If the ship should take on some water by mistake during a storm, it's simply pumped out into the ocean and saved from sinking once more. What we're going to do is prove this theory with a bowl of water, a quarter, and some aluminum foil. A lot of very easy tools to have around the house. First things first, I have a giant bowl of water. I then have 10 quarters and some aluminum foil. What I'm going to do now is I'm going to show that by itself the quarter, which is not displaced in the water properly, will sink to the bottom of the water. And to the bottom of the water. I'll now show that the ship, our little aluminum boat that I have already changed, will be distributing the water properly, which means that it will stay afloat. Boom. The boat remains afloat. Now what we're going to do is we're going to put all 10 coins that I have, all the quarters, and we are going to place it into the middle of the boat. We will see if it's able to hold up the weight. Placing it right in the middle. And unfortunately, no. The boat sinks to the bottom of the water. Why does this happen? This happens because the boat is not distributing the water properly. All the weight is in the middle and dragging it down. Thus, the water is not displaced and the boat sinks. We'll now take our boat out of the water. We will then take these 10 quarters and we will try this again, but by displacing the weight of the quarters a little more evenly, the boat will stay afloat. So we will use all 10 quarters again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now we see the boat is remaining afloat even though the same 10 quarters are inside the boat. Why does this happen? Because the weight has been distributed evenly on the outside and not all forced in the middle, which pushes the weight of the water down, sinking the boat, making the water come into the sides and making it crash to the bottom. This same theory is used with most boats on the sea, that by displacing the weight evenly and having a solid hull, having a hollow hull keeps the boat afloat. The more weight you add onto it, you overextend its capacity and makes it sink. With this, we learned today that buoyancy keeps boats afloat with buoyancy and using the distribution of water properly. This is Joshua Scabry. Thank you very much and have a nice day.